I guess I should have made this video about 5, 6, 7 years ago, but I'm a procrastinator of the highest order, and shit gets in the way. Life goes on. What you're looking at here is a Wicked Edge first generation vise for clamping a knife, and the purpose of this video is to demonstrate why this is the correct way to mount a FFG, or a full flat ground blade in the Wicked Edge vise. And I suppose technically it applies to any of the 2 screw vices that are on the market with other knife sharpeners. I don't know if you can see it in this view, but what I have is a blade. It happens to be a full flat ground Spyderco blade. Give you a little bit different view of it here. It's out of a Resilient, which is one of the lower end Spyderco knives. I've got several other full flat ground blades here that I'll use to demonstrate for you. But the principle is that there's a fixed jaw on the left, and there is a variable or adjustable jaw on the right. And what I'm proposing is that the correct way to mount a blade in the vise is with a flat surface against the fixed jaw. And with a full flat blade, that means that you have to lean the blade to the side with the fixed jaw on it. Effectively, what's happening is that the blade is leaning at about half of the angle displacement of the blade. For instance, the difference in the angle on one side of the blade to the other is about 4 degrees, and that means that our blade is leaning to the left about 2 degrees. Okay, now what I'm going to demonstrate for you is why the correct way to mount this thing is with the adjustable jaw being flat against the opposite face of the blade. Now, I'll go through a couple of different demonstrations of this. I'll teach you why clamping the blade in this configuration is the correct way to do it, and I'll also show you how to measure the displacement between your blades so you know how much the blade is leaning to one side. Where you have a 4-degree blade and it's leaning 2 degrees to the left, that means you subtract 2 degrees from the angle adjustment of your sharpening jig on the left, and you add 2 degrees to the sharpening jig on the right, and you'll end up with a symmetrical bevels. Now there's a couple of ways that you can measure what the displacement is of your blade. In this case, let me show you how I would do it in this position. Rather than using the key on for setting the height of the blade, what we want to do here is set the blade entirely down on top of the screw, so I've got a large surface area to measure from. And then I would pinch the blade on the top, and I can take an angle reading on the right hand jaw. What I should have done first is let's zero our angle cube. I'm going to zero it on the face of the vise over here. Okay. Make sure I'm set up right. And now I can put the blade in so it's set down on top of the screw, and I can pinch the vise to the right, and now I can measure. Oh, I must have push the button again. Nope, I must have re-zeroed it. Sorry about that. There we go. Pinch it together and now measure it. And I'm getting about a 3.46 degrees for the difference, 3.5 degrees for all practical purposes. Let me make sure this screw isn't affecting my reading. And there I have 4.19 degrees, 1/8. That is about 4 degrees. So that means that my adjustments would be offset by the 2 degrees. Now there are a couple other ways that you can measure the angle of a blade. Let me show you one that works very well. I'm going to readjust the camera here. One way is to take the blade and set it on the surface that you've got your angle cube zeroed to. Okay. Now I have a piece of ground steel that I use as a plate on there, and I can set it on that blade and I will get a fairly good representation of the angle. This is 4.4 degrees. There might be some dust under here. I found that I get a little bit more variability over here, but generally it'll get me within the degree. We've got a couple other blades that we can do it. This is that's a full flat ground that I did. It's not fully flat. Here's a Delica, which I know is about 3.7 degrees. And there we've got 3.79 degrees. And I've got a Stretch, which is a little over 4 degrees at 4.3, 4.4. Again, this measuring it is helpful to tell you how much to offset your angled adjustments. Okay. Now, of course, when you actually are mounting the knife in the vise, you will want to use the key to set it to the height that you want. Okay, and you want to pinch that vise so that it's sticking out, and then you run the other screw in and crank on it. And what you're doing is you're pressing the flat of the left flat of the blade against the left vise. So now you know that the blade is leaning 2 degrees to the left. Okay. When you adjust the vise for any blade, whether it's a full flat ground or not, if it's parallel sides, what you want to do is start out with your jack screw backed off, and you set your gap with the if it's a parallel flat thing, you want the gap at the bottom to be the same as the thickness of the blade. And then you can, I'm working with opposite hands here because I'm trying to give you a decent view of it. Okay, now I can crank on it, and the blade is going to be held vertically. That's assuming it's a blade with parallel flats on it. Okay, now I'm going to move the camera here and get set up for something else here. Okay, what you're looking at is this is a screw clamp. Actually, I got to turn it around. It's called a hand screw clamp. Woodworkers have been using them for hundreds of years. What I did here for our purposes, I screwed the left-hand side to a baseboard here, so it emulates the basic principles of the wicked edge vise. There's two screws on here, hand screws, and what they are is they have opposite threads screwing out from left to right. So they're a left-hand thread on one side, this one, and a right-hand thread on the other. And then there are pivoting nuts inside these pivot joints. Now, you loosen up on the bottom screw just like you would the wicked edge vise to adjust the bottom, and you use the top screw to adjust the opening of your jaw. Now, in the case of a blade with parallel flats, what we want to do is have this opening be approximately parallel. And let me show you why. I have a piece of wood here that I've cut so that it's parallel in one side, and if I turn it, I've got the equivalent of an FFG blade. So let's start out with here everything looks good, and if I can tighten it, and this thing is really held tightly, except that you can see there's a little daylight, a little bit of opening at the top, and that means that this thing can move as I put load on it. Now this is 10 times as big as the wicked edge vise, but that's just for demonstration purposes. Now, that means that I've got to screw in too far, and this is exactly what you can do with the wicked edge. You can have it screwed in too far, and you'll end up getting some rocking of the knife in the vise while you're working on it. So you have to be aware of this condition to avoid it. Now, likewise, I can unload this thing and I can back this thing out too far, and let me back it out a little farther, and I can clamp it like that, and now you see I've got a little opening at the bottom, and that thing can move slightly in that vise. So the correct way to clamp a blade with parallel sides is you have to get the gap set properly so that your vise sides are parallel. This is a little more difficult because the bottom screws are fixed. Oops, I went too far. Huh? Oops. When I get them clamped properly, it'll hold it solid in there. You won't get any movement at all. Now let's go to the full flat ground version. Here the blade is obviously, and this is a 4-degree angle on it, just to try and make it more accurately represent the average blade. And what I have to do now is I have to jack out that movable side in order to clamp that blade fully on that side. Now I've got it clamped pretty much where I've got full contact through the top of this, and there's no movement side to side. If I have this thing turned in too far, now I'm clamped at the bottom of this block, and the thing can move in the vise quite a bit. And likewise, if I clamp it too far out, and now everything feels like you've got a good pressure on it and everything, but this thing can move now in the vise because of the openings at the bottom. Now, if it's difficult to believe this, then consider if this was a steel vise, or aluminum for that matter, and the blade was ceramic or glass, where it's slippery, and you're going to get some movement, and it's going to tend to skew out, and you'll lose control of whatever you're holding in the vise. So that should show you why the correct way to do it is with the sides of the vise being parallel to the sides of the blade, or they should lay flat on it. Now, some people will wrap chamois or tape on a blade in order to give them a tighter fit, and that's fine. You can do that, but you should confirm that you have absolutely no movement in the blade. If there is any movement at all, you'll see a change in your scratch pattern as you're moving, or you'll find that you'll take a reading on your angle cube, reading on your angle on one side, and you'll take another reading a little while later, and it'll be different. That's because this thing has moved in the vise. It'll actually won't just spring back and forth. It'll actually move, and you push it in one direction, it'll stay there, and you push it and go back the other way. If you're going to use a tape, you ought to use a tape that is positive. It's not going to be smushy. Again, if you can tighten up on the vise and make something like chamois work pretty good, many guys are doing that. They've been doing that for a long time. What I'm trying to demonstrate here is the correct way to do it. Once you understand the correct way to do it, then it'll be easier to avoid mistakes. Okay, let's go back to the wicked edge vise. I wanted to show you that, if I can get in there closer here. When you put a blade in the vise, whatever kind of blade, I'm not interested in precision here. I wanted to demonstrate something for you. That has to do with the amount of force that you apply on the screws. The top screw should only be adjusted to set the gap just below the blade, and then the bottom screw should be turned in order to give you the force that you need on the vise. But you only need to have between 1/4 and a half a turn of crank on this force applied to the bottom screw in order to make it tight. Let me see if I can get my hand over here. Now I'm loose here, and this is a 1/4 turn, this is a half. I would never go beyond that. It's not necessary. If you don't have a hold of the blade with a half a turn of force on the bottom screw, then you've got the blade mounted incorrectly. What happens to most people who don't seem to adhere to this, or they don't really understand it, is that they tend to over tighten this in order to securely hold a problem blade. And what happens is that they end up bending the vise jaws at the top. And let me show you something that what I have done. Here you take a look at this vise, and you'll see that there's there's shiny areas on here. And what I've done is I've draw filed this vise because I had about 1 degree of bend in the top of the jaw that I had accumulated over maybe 5-6 years of use, maybe 7 or 8 years, and I only had about 1 degree of bend at the top. But what I did notice was that if I back the bottom screw out, okay, and if I could squeeze the vise at the top, and if the bottom would kick out, that means that the top of the jaw is bent, okay. And you can go to Wicked Edge. They got just outstanding customer service, and no doubt they'll give you a replacement set of jaws. But fact is that it's probably your fault, and you've over-tightened it. And what I found is it's a pretty easy way to fix it. I'd lay it on a mill file, which I had set in a vise, and I just stroked the face of the vise or this jaw across the top of the file, and I would put Sharpie marks, actually magic marker, to blacken the face of it, and then I would check to see where the high spots are. And it's a pretty easy way to get the vise back to a flat condition. When I started this a week ago here, I noticed that when I squeezed it at the top, I would get about the bottom would just kick out perceptibly. And I noticed that when I measured the blade's angle using the side of the vise, it would be about, when I pinch it together, it would be off by about 1 degree. And I found out that it was the jaw was slightly bent at the top. And all it took was a few minutes on a draw file to flatten that face and get it back into a good condition. I don't remember did I do the... Yeah, I think I did the other one too. I did both jaws to flatten it. Didn't take much at all, and they're back to being straight. Now, if you've really been cranking on your jack screw, you probably bend it enough that it's probably not easily repairable with a filing method. So there you might want to go to Wicked Edge and either ask for a warranty repair or buy a jaw outright for them. If it was my fault, I'd offer to pay for it. But you're on your own, and I hope this helps you. Have a good day, gentlemen.